Hi everyone. In the previous video, we saw how to create the hobs, right? Which is build a GUID hob. So hobs are mainly used to transfer the data between the PIMs or from PI to Dixie. Okay, so the hob is nothing but hands-off block, meaning we are going to transfer some data from one phase to other phase. Okay, so it can be any type of data. In this case, they are giving the example of a memory bank discovered, right? So there are different types of data which we can pass based on its associative GUID. Okay, so is this the only way where we can create the hobs using this build GUID hob? No. Based on our use cases, there are multiple ways of creating the hobs. This build GUID hob is one of the way. Okay, so we have explored this build GUID hob in the hops part one session. Okay, so now we'll go to a part two where we will explore the other ways of creating the hops. Okay, so I will go to our EDK2 source, right? So yeah, so we have explored build GUID hops in the part one, right? So now we'll explore build GUID data hub this time. Okay, so what is the difference between this build GUID data hub versus this build GUID hub, right? So in this build GUID hub, the data what we want to pass, right? So that is not yet available. Okay, whereas in case of this build a GUID data hub, the data which we have to build the hub, right? So that is available before we build the hub. Okay, so meaning if the data is already available, we can use the build GUID data hub. So if the data is not yet available, then we can use the build GUID hub. Okay, so internally this build hub is internally using this build GUID hub only, but it is doing one additional steps, which is a copy mem, right? Because the data is already available. So what does it do? So it will build the hub first, and then it will do the copy to that hub based on how much size we are going to give. Okay, so let's explore, right? So we'll go to emulator package here. Okay, so we'll go to include GUID and we'll create one hub, right? So probably I will copy paste this and I will call this as a um, sample data hub. And accordingly, this preprocessor directive also I'm going to change sample data hub. Okay, and this preprocessor directive it is not needed. And yeah, let's remove this members of this data structure. And this GUID also it's not needed as we are going to create a new one and where it's going to directly take from the INF file. Okay, so now let's say uint 64, a variable one, and then uint 64, which is variable 2, and then uint 32, again variable 3, right? So now we have a data structure. So where it contains mainly three members, right? Variable 1, 2, and 3. So let's call this hub. We'll call this hub as a sample hub. Okay. So now let's pick any driver where we are going to build the hub, right? So let's go to our FDF file and let's see, right? So maybe I will take this boot mode PI or maybe this autoscan PI or any module, right? So maybe let's consider this autoscan PI. Okay. So now here I'm going to build the hub, right? So first we need to include the header file. So hash include GUID slash sample data hub. Okay. So now in this sample data hub, so our hub name itself is a sample hub, right? So this is our entry point. So let's double confirm. Yeah. So PI initialize autoscan PI. Yeah. This is our entry point. And let's use our hub, right? So sample data hub. Okay, and it's going to be a pointer. I will call this as a sample hub. Okay, so now so now it's just a pointer, right? So now for that pointer we need to allocate some memory. Okay, so now maybe at the end, what I'm going to do, sample hop is equal to allocate zero pool. Okay, so now what is the how much memory we needed, right? So I need a size of our hop data structure. Okay, so which is this one, sample hop. Okay, so now so now this sample hub is pointing to some memory location. Okay, so now let's fill. So first we need to check whether the allocation is happened or not, right? So how we are going to check? So first we are going to check for the null pointer. So if the sample hop is equal to null, so then which means the allocation is not happened. In such scenarios, so we will do the assert. Okay, so assert, and then sample hop not equal to null. Okay, so either it's a false condition, right? So which ultimately is going to return false. This is another way of returning the false. Okay, so assert false. Both the statements are true. Okay, so which means assert works in the reverse order. So if the assert false means assert will hit. So sample data hub is not equal to null. It's a false condition because it is null, right? So now this assert will hit. Okay, so now this assert I'm going to remove, and then in case of the release BIOS, assert will not hit. So in this case I will do simply return from here. Okay, so now okay, so now we know that we have some memory location, right? So now we will fill the data, right? So what we are doing, so we are going to build the build GUID data hub, which means the data should be available before build the hub. So now let's build it, right? So sample data hub, so variable one, zero cross deadbeef deadbeef, right? So it's a uint64, right? So now variable two, again it's a uint 64. Now let's do 1, 2, 3, 4, 5, 6, 7, 8, A, B, C, D, E, F. Okay, and then we'll do 0, 0. And then we have the third variable, variable 3, and then simply I will do maybe A, B, C, D, E, F. Okay, so now the data is already available. Okay, so now let's build the hub, right? So build GUID data hub. Okay, so now this build data GUID hub, right? So let's see what are the arguments it's going to take. Okay, so first it needs a GUID, the data pointer, and the length. So let's create the GUID, right? So now this module is already including the emulator package.exe. So now let's go to our GUID section, and in the GUIDs, let's create a GUID, right? So Control Shift P, insert GUID, and the data type which we are looking for is this one. And now here, let's remove this. Okay, so now we'll type G hemu uh, sample data how GUID. Okay, so let's make the alignments and we'll remove the semicolon at the end. So just to make sure everything is aligned. Okay, perfect. So now we have our GUID ready, right? So now let's include these GUIDs in our AutoScan PI. So here GUIDs, under the GUID section header, we will include that GUID. And now this GUID, we are going to produce it, right? So it's just for readability. This comment is just for the readability. It does not have any build time use case. Okay. So now we got the GUID. So now let's go to our AutoScan PI. Okay. So address of that GUID. Okay. And then the second argument it needed is the data. Okay, so now the data pointer, it is already a pointer, so we will simply pass a sample data. Okay, and how much size we are going to build the hob. So size of our data structure. So what is our data structure size, which is the sample hob. Okay. So now it ends with the semicolon. So now we have built the hob, right? So let's see at least whether the build is working fine or not with this, right? So now before we build it, so let's see, are we including any hob lib? Yes, so we are including this hob lib. And is this INF file is including the required hob lib? Yes, it is including. Okay, so this hob lib is ultimately will point to our build a data hob, right? So where is the function definition it is coming from, right? As you can see, the hob is coming from the ARM embedded MD, and within this MD package we have the Dixie core, Dixie, and then we have our PI, and then standalone MM, right? So we need to specify where exactly that hob lib is coming from, right? So I'm assuming we are going to get the hob lib from this MD module package, and so since it's a PI module, so it's going to pick from the PI hop, right? So that we can get the confirmation. So I will copy this INF file, and so since we are running on the emulator, so I will open the emulator package.dsc, and if I search this, so here we can see, right? So this is nothing but this hob lib. So this hob lib is used for PIM and the PI core. So this is what we can get the confirmation, and there is another way of getting the confirmation which hoblib this module is going to get from the build folder. Will once we build it, right, we'll show you. So now let's build it. I will open the command prompt. Okay, so I will do edk setup dot bat. So since it's a Windows, so I'm going to run the bat. If it is if you are running on the Linux environment, so you're going to run the run this edk setup dot sh. Okay, so now let me maximize this. To use this. Okay, yeah, perfect. So now I will simply clear the screen and then I will do build. Okay, so now we'll wait for that build to happen. So since it is already built, so it's going to build only the modules which are modified. So through that it is not going to take much time as it's an incremental build. Okay, so now we got the error in line number 105 where this allocate zero pool it does not know what it's because it's undefined, right? So now let's see, right? So we'll go to our autoscan PI and let's go here, right? So here we are doing this allocate zero pool, and this allocate zero pool where is the function declaration is coming from star.h, and it is coming from the memory allocation library. Okay, so now let's include that header file library slash memory allocation lib, and that same memory allocation lib we have to add it in the INF file because it is taking the, so now adding the header file meaning it knows where to pick the function declaration from. So adding that in the INF file, we are going to tell the compiler go ahead and pick the function definition from this library, and this library definition ultimately it is coming from the DSC file, and it is going to pick the function definition from this INF file, and ultimately it will come to here, and here let's search for zero pool. Yeah, ultimately when we call the allocate zero pool, ultimately it will go ahead and call this function. Okay, so now let's build it again. It's building. Okay, so we ran into an error. So in line number 109. Okay, so now let's look at autoscan PI and 109 here. Okay, so what's happening here is if you look at this function here, right? So it is expecting a return type as a EFI status. Okay, so in our case, so since we are not returning anything, so that EAX register will be pointing to none, right? So it is not having any value in the EAX register. So let's do it. So EFI underscore out of resource. Okay, because we are not getting enough resource to build the zero pool, right, which is ultimately we are not getting enough memory to proceed further. So now let's build it again. So if this build works fine, so we are assuming that the Hob build is working perfectly fine. Okay. And then once we build it, right, so we'll locate it again just to be make sure, and we will read the data again, right? So to verify whether the data is actually being written or not. Okay, so now our build is successful. So as I mentioned, right, so we'll see where that allocate the hoblib is picking from, right? So I will show you. We'll go to build emulator IO32 emulator package, and then we have the autoscan PI. So autoscan PI output, and here we have another INF file. Okay, so if we search for this Hob here, yep, here you can see. So this is a Hob which we are creating, and you can see it's still a comment because it's produces. Okay, so now here you can see MD module, MD package library, PI hoblib, PI hoblib.inf file, which means this autoscan PI is taking the Hob library from this INF file. Okay, so now let's pick the another library where we will uh, get the Hob, and then we will see whatever the data which we have written, right? So whether we can able to read it back or not. Okay, so let's pick a random driver, maybe firmware volume PI. Okay, so we'll go to firmware volume PI, and we need to know the INF file. Sorry, it needs to know the GUID of that Hob which we want to locate, right? So let's copy this GUID. Does it has any section header GUIDs? No, it does not. So we'll use it. Okay, and this time here it is consuming it. Okay, so let's align it. So now we'll go to its C file. So now we need to include the header file hash include GUIDs GUID slash sample data hub. Okay, so this is our entry point. So where it is taking the handler as an input, right? So now here sample data hub. Okay, sample hub. Okay, and we need to get the hub, right? So EFI underscore hub underscore. It's a GUID type, right? So we are looking for it's a GUID type, and then it's a GUID hub. Okay, so now because we need to get the sample GUID hub, right? So because that's the reason we are going to give the GUID hub here. Okay, so now maybe let's go to the end. Okay, so at the end, before it returns, so we'll do this. GUID hub is equal to get first GUID hub, and then we need to pass the address of our GUID, which is nothing but this emu sample GUID data hub. Okay, and then semicolon. Okay, so now if the hub is not found, then we will check for the null hub, right? So if the GUID hub is equal to null, which means the hub is not builded, so then we will take the appropriate traction. So in our case, let's not assert it. So we will simply return EFI underscore maybe aborted. Okay, because hub is not available. Okay, so now assuming the hub is available, so sample hub is equal to get GUID hub data. Okay, and then we will pass the GUID hub. Okay, so now the sample hub is actually pointing to the hub which we have built it. Okay, so now let's print it, right? So debug underscore info, and then let's do this, right? Percentage a, and then maybe a percentage d, and then sample hob is equal to 0x percentage Alex. Okay, so and then we will do sample hob. Okay, and then we'll print the variable one, and then we'll paste variable two and variable three. Similarly, we'll update the here, and this is not Alex because this variable three is uint 32. Okay, so now build it again. Okay, so meanwhile it builds, right? So we'll go to build folder, emulator i32. Yeah, build is completed. So emulator i32, debug i32, and here we have the winhost. Open the command prompt, and then we will run the winhost, and we will redirect this bias logs to some file, right? So boot.log to ampersand greater than 1. Okay. Okay. And now let's see what's happening. Build emulator i32 boot.log, and here, okay. So sample hop, it is printing the pointer, but here it is coming some junk value, junk data, right? So let's see. All right. So here we have this percentage A and percentage D, which we missed to add it. Okay, so let's add it. So underscore underscore function underscore and then underscore line. Okay. So now let's close this, and then let's build it again. Okay, yeah, build is completed, and let's run the same command again. Okay, so now we can see UEFI shell popped up, and let's see the boot.log here, right? So sample hop, let's search for this string. Yep. So the sample hop is pointing to this memory location, and this memory location has this data deadbeef 1 2 3 4 ABCDEF and then ABCDEF. This is what we have builded, right? So now we have builded the hub in the PI phase, and we have located the hub in the PI phase, right? So now let's try to locate the hub in the Dixie phase, right? So it's the same process, no difference. Okay, so let's pick one Dixie file here, right? So maybe let's pick this Metronix, right? So metronome, okay. So I will copy this. Does it has this GUID section header? Yeah, it does not have. So we'll close the all other files, right? So which are not needed. So we need this. So we'll copy this. Okay, and we'll go to its C file. Okay, so here we will include the header file. Sample data hop, and then we need the C file. So we'll copy this. We'll go to its C file now. And here, wait for take. Yeah, image handle. Yeah, this is the entry point. And here we'll add this. Okay, and then we'll copy paste this. Okay. So does it include this hoblib? Nope. So let's add this hoblib, and here it does not have the hoblib. So hash include library slash hoblib.h. Okay. So now we don't know whether this this INF file, whether it is including the actual debug libraries or not. So we need to check here, right? So for now, I'm going to copy paste this so that I will get the actual debug logs for this. Okay, so it's just simply I'm including this base serial port library and debug library, and this serial port I'm going to take it from the DXEMU standard error library. Okay, so before we build it, so let's exit and then restart, and then here Control C, and then we will build it once again. Okay, so we got the error. So here it says emulator Hob it does not found. Okay, so now why it does not found? So let's go back here, right? So if you look at, so we are using this GUID, but where this GUID is coming from, this INF file does not know, right? So because in this packages, it is including only MD package.dec. Okay, so now let's include the emulator package.dec as well, because this is where our actual GUID is coming from. Okay, so now let's build it once again. Yep, it started building. Perfect, it is built it, right? So now let's go back and run the same command winhost. We will redirect to boot.log. Okay, so UEFI shell got popped up. And now let's go back to our boot.log. Let's search for our sample hub, right? So now this is what it is coming from the PI phase, where it is firmware volume.pi. Okay, and then we'll go to our Dixie, which is this metronome.efi, right? So if you look at this data, which is exactly matching with the previous data. Okay, so now I will copy this and let me open the beyond compare. Okay, so we'll copy this, which is coming from the Dixie, and let's copy the data from the PEI. Okay, so now if you look at the difference between the PI and the Dixie, right? So now the whatever the data which we have written, which is variable 1, variable 2, and the variable 3 are still intact. Okay, so the hop pointer is changed from this D19 followed by this to this address. Okay, so this is because from the PI to Dixie there is a migration from the temporary memory to the permanent memory, and that's the reason the pointer is getting changed. But in our case, whatever the data which we wanted, so that is still intact. Okay, so now let's go back to our favorite paint. So now let's draw this diagram. Okay, so we have our sec phase, and then we have our PI phase, and then we have the Dixie phase. Okay, and okay, so at this point, okay, so we have build the hub. Okay, and somewhere assume in this phase we get the hub and then we have printed. So in our case, we are just printing, but in our case, we can actually use the data. Okay, and then similarly in the Dixie phase, somewhere here, we got the hub, and then we saw that the data, whatever the data which we have filled in the PI phase are still intact in the Dixie phase as well. So which proves that it is used to pass the data from the PI phase to a Dixie modules or Dixie foundations. Okay, so that's it for today. Thank you.